Welcome back to our attendees. Our next speaker, Mr. Rami Shabaneh, Senior Research Associate at CAPSARC, speaking on today's topic, Understanding the Hydrogen Production Prospects in Saudi Arabia. Over to you, Rami.
Thanks, Melvin, and thank you for the invitation. Really delighted to be here today. If you don't know about CAPSARC, CAPSARC is a research think tank based in Riyadh. We focus on energy and policy research. So my presentation today will focus on assessing the cost of production in Saudi Arabia, cost of production of hydrogen, that is, in Saudi Arabia. And given the tremendous activity we've seen in the past 12 to 18 months here in the kingdom, it's really important to know how Saudi Arabia fares against other hydrogen players, and what would that mean in terms of resource needed, and whether it's for export or for domestic use. So as we all are aware by now, Saudi Arabia started its hydrogen journey with a bang last year with two milestone announcements. The first one came in July of last year to build the world's largest green hydrogen plant in NEOM, which is a new city in the northwest part of the country. This is a $5 billion project, a joint venture between NEOM, Aqua Power, and Air Products. It's going to utilize 4 gigawatts of renewable electricity to produce about 650 tons per day of green hydrogen, and that will be converted to ammonia, all of which is earmarked for exports so far. And it's so far on schedule with a starting date of 2025. On the other side of the map, in the eastern region, Saudi Aramco, along with SABIC and the Institute of Energy Economics Japan, announced a successful shipment of blue ammonia, about 40 metric tons to Japan, where Japan is piloting directly to burn the ammonia directly in power generation. This was just a one-time demonstration shipment with the aim to see if it could be done and test out the supply chain, and to see where it could be further optimized to possibly take it to commercial deployment in the future. So these two projects display the potential Saudi Arabia has, given its resource in low-cost hydrocarbons, low-cost renewable energy, and of course, a significant amount of geologic pore space for CO2 storage. In addition, there has been a number of MOUs and bilateral cooperation between Saudi Arabia and its strategic partners, both in the country level and a commercial entity level. The most recent one with Germany, and then Aramco signed another one with Hyundai Heavy Industries Holding to investigate both the areas of blue and green hydrogen. So really, there has been tremendous momentum behind the kingdom these past couple of months. Here I want to continue the discussion to highlight some of the thoughts around why Saudi Arabia is well suited to become a hydrogen producing hub. It has a lot of characteristics to make this plausible. First, Saudi Arabia has a lot of industrial experience based off of their oil and gas industry. There are large refineries and chemical bases. They produce a lot of hydrogen. They have experiences with CCS. They have a CCS plant, which is one of the largest in the region. Secondly, they have the economies of scale. They like building things big here. Facilities are usually built much larger than other places, which give them an additional cost advantage. A lot of the industries are built at world scale and they're export oriented. So they have large infrastructure in place, as well as industrial ports to go along with it. Thirdly, the region has a geographic and logistical advantage. Not only is it blessed with the resources to make blue and green hydrogen, but it's located within easy shipping distances to large growing clean energy markets, I would say. The project in NEOM, for example, is well placed because it's in the Red Sea coast next to the Suez Canal and can go directly to Europe if it wishes to sell there. Another advantage is that Saudi Arabia has a counter-cyclical energy demand compared to its potential hydrogen buyers. Most of the energy demand requirements in Saudi Arabia is during the summertime, and that's primarily for air conditioning. But during the winter, where there is high demand for energy in, say, Europe or Asia for heating, the demand is low here, so they can take advantage of that seasonal pricing. And last of all, the funds were investments. Being or having a centralized governance structure allows you to set projects, like NEOM, put money forward and towards it and push such project forward, especially for a nascent industry like hydrogen. From a resource perspective, theoretically, Saudi Arabia is able to pursue, a solely blue hydrogen or a solely green hydrogen strategy. But it is important to remember that Saudi Arabia is a large country, the largest in Western Asia, and its resources is not distributed equally across its landmass. From a cost perspective, a low-cost solution can be met by developing both pathways simultaneously. So if you look on the map, for example, on your right, in the eastern side of the country, that's where all your oil and gas fields are located. So a lot of the infrastructure and industries are built around there. So it makes it ideal for blue hydrogen production. In fact, the blue ammonia shipment that was sent to Japan was sent from the eastern province, from the East Coast, and it leveraged on the existing infrastructure, stringing these ammonia plants with the sources of gas and tying into the existing CO2 capture plant. Where in the Western region, there's hardly any oil and gas development, and there are infrastructure bottlenecks, which means that bringing gas to the eastern or from the eastern fields all the way west might be costly, and even the options for storing and utilizing CO2 may be expensive. But the Western region is known for its world-class renewable energy resources, especially in that northwestern part of the country. That's where the existing renewable energy plants are currently located, and future development plants will be located there, including that project in NEOM. So it's very important to understand the resource landscape and taking that into account. And of course, it's pretty apparent from the Circular Carbon Economy Framework, which was adopted during Saudi Arabia's G20 last year, that Saudi Arabia will follow a cost-effective and a pragmatic approach to mitigating CO2, which is a technology agnostic approach, basically. So this will allow an opportunity for both blue and green pathways to be developed if they deem economic. All right, so the drivers behind this low cost. So here I want to zero in on the cost of production of the resources, starting with the renewable electricity. Clearly, there has been a declining trend in auction prices for renewable energy projects in Saudi Arabia since 2018. The winning bid, for example, at Sakaka PV plant back in 2018 and Umm Al Jandal wind farm in 2019 had a PPA price of around $23 per megawatt hour. But the auction prices for the last round of projects that were approved in April are much lower. We're seeing record-breaking prices. We're now testing that $15 per megawatt hour threshold, and even just hovering slightly above $10 per megawatt hour for some projects, notably the Shuaiba PV plant. So we're seeing significant decline in costs. On the natural gas side, Saudi, they're ranked now with the 5th or 6th largest gas reserves in the world, according to their last audit. So it's massive. And the domestic prices currently are one of the lowest in the world. And it's been a driver for industrial growth in the country. And a large portion of the gas production is associated with oil. But it's important to note that future developments in gas projects will entail more non-associated gas and possibly non-unconventional gas, which come with a higher cost. And that may eventually be reflected in the domestic price. Having said that, there's still a good cushion to remain competitive priced in this field. So what does that mean for hydrogen cost? Well, at CapSarc, we ran the numbers. We ran them for the three colors, gray, blue, and green, including gray hydrogen from electrolysis or grid-based hydrogen, which is the most expensive option given the high industrial tariff. But if we compare it to the conventional technology of gray hydrogen from an SMR, that is the cheapest method to produce hydrogen, and that's due to the fact that natural gas prices are extremely low, and there's no requirement, of course, to capture the CO2. So currently, gray hydrogen could be produced at just less than $1 a kilogram, $0.9 per kilogram to be exact. But looking at the clean hydrogen production, blue hydrogen has a head start over green. currently, again, thanks to the low gas prices and the cost of the capex required compared to the green hydrogen. So currently the cost of blue hydrogen comes to about $1.34 per kilogram. But of course, again, this is highly dependent on the natural gas price. Green hydrogen is more expensive than blue today at the moment. Here we used about $18 per megawatt hour, which is the average price of the 7 projects that were recently approved in April for renewable energy projects. Now, this is still low compared to other parts of the world, like Europe and US, where you see green hydrogen projects currently north of $5 per kilogram. But it's still the most expensive option currently. Now, going forward by 2030, we expect to see a significant drop in cost due to scale up of clean hydrogen production and technology improvements. If we look at blue hydrogen production in Saudi Arabia, we expect production cost to drop by about 16% by 2030 to about $1.13 per kilogram, assuming natural gas prices don't change. The biggest driver behind this drop is the cost of carbon capture technology, which is expected to drop by about 20% within the decade. That's according to the IEA. However, if you look at the tornado chart on the right, blue hydrogen economics are highly sensitive to natural gas prices. And those, of course, are directly related to the development cost of the gas fields. And I will show a slide later in my presentation comparing green and blue by 2030 to see at which price that blue hydrogen may stay competitive. In terms of green hydrogen, the rate of decline is expected to be more than blue hydrogen. We expect to see hydrogen fall from the $2.16 per kilogram today to just under $1.50 per kilogram, so about a 31% drop in cost. The main driver behind this, obviously, is the renewable energy price, which we assume would average $13 per megawatt hour by 2030 versus the $18 today. And of course, the electrolyzer cost, which also drops from $900 per kilowatt to $650 per kilowatt. In the long term, especially if we continue to see $10 per megawatt hour renewable electricity price, you could well see costs reaching around $1 per kilogram. As especially if we see a lot of the Shuaibah PV prices replicate throughout the Saudi electricity prices. And bringing those renewable electricity prices is extremely important for green hydrogen to work. As you can see on the tornado graph, those prices are the electricity prices are sensitive to the costs. So the chart here summarizes basically the chart on the left summarizes the cost of production of the technology for both the years 2020 and 2030. So you can see that the cost of hydrogen sees the biggest drop. However, the blue hydrogen remains competitive by 2030 if gas prices remains constant. But we estimate if gas prices increase to $3.25 per MMBTU by 2030, it would reach cost parity with green hydrogen. So, so how do these costs translate in the export market? That's what the chart on the right shows. It estimates the delivered cost of green hydrogen from northwest region of Saudi Arabia to Rotterdam by the different modes or the different hydrogen carriers. And if you contrast this with the cost range of hydrogen production cost in Europe, Saudi deliveries can be quite competitive. Ammonia as a hydrogen carrier is in the far right, the chart is the favorable carrier, given the experience we have in ammonia supply chains and the maturity of the technology compared to transporting liquid hydrogen or in the form of liquid organic carrier. But that last step shown in yellow of reconverting that ammonia back to hydrogen could be quite significant. So it could add anywhere between $1 to $2 per kilogram to your total delivered cost. This is actually one of the reasons why Japan has chosen to pilot direct use of ammonia in power plants rather than cracking the ammonia back to hydrogen to avoid that extra cost. We also ran a thought experiment, similar to what Hydrogen Council did in one of their reports. This thought experiment is just to see how much resources will be required if Saudi Arabia would have a policy to use hydrogen domestically in their energy mix. We kind of extrapolated what the final energy demand would be by 2030, kind of using historical growth, and then assumed a certain percentage of hydrogen penetration to meet that demand. And if, for example, Saudi Arabia has a target to have a 5% of hydrogen in the energy mix by 2030, which comes to about 2 million tons per year, and say that it was only met by green hydrogen, it would require 20 gigawatts of electrolyzers, about 44 gigawatts of renewable energy. To put that in perspective, you would need about 10 NEOMs or 10 of the NEOM projects to achieve just that 5% penetration of hydrogen. Similarly, to meet the same amount by blue, you would require to develop a field that would give you about a BCF a day of gas continuously, which is basically 10% of the current production. So basically, this shows that just picking one route, may be more costly, and maybe you'll reach a more optimal solution if at least in the short term and the medium term, picking both pathways, blue and green. I want to finish with this takeaway at the end, just to summarize my presentation here. Saudi Arabia is endowed with a vast amount of low-cost hydrocarbons, low-cost renewable energy resources, and plenty of quality pore space for the geological storage of CO2, and could be a low-cost marginal supplier of hydrogen and still maintain its role as a preeminent energy hub in the energy transition. It's important to understand that the resource allocation in the kingdom and to take that into account to kind of squeeze the advantage of that low-cost blue and green hydrogen, because as we saw in my previous slide, choosing one technology over the other, at least in the short to medium term, may require more investment than a combined strategy. But from the cost economics, what we see today is that blue hydrogen, has a head start over green hydrogen. Further declines in capex are expected with scale up. But like I said, these cost of hydrogen is highly sensitive to natural gas prices. Green hydrogen, on the other hand, could well reach $1.50 by 2030, and even below in the long term if we achieve very low electricity prices. And again, the CCE framework that was adopted by the G20 is expected to be the main driver to support these hydrogen projects. However, implementation requires addressing these challenges when it comes to regulatory and putting the incentives there for these developments to happen. So I'll stop here, and I'm happy to take any questions if there's any.
Thank you, Rami, for your presentation. It was quite detailed, though. I checked, and it was quite exciting too. So we see a great potential in Saudi Arabia among other countries too, but I think Saudi Arabia is right there on the top with its plans on hydrogen, I believe.
Yeah, that's right. They really put the wheels in motion, especially with the project in NEOM. That's going to be the largest. It's on schedule. They already contracted the volumes to Air Products being the main off-taker. So it's exciting, and with the blue shipment ammonia, the blue ammonia shipment that was done as well, that was successful. That was the first of its kind, and we've seen the UAE, selling 3 cargoes as well. But this region in general is just could take advantage of the resources. Just incredible how much they can, or how cheap they can produce both blue and green hydrogen.
Correct. So where's the bigger emphasis given in Saudi Arabia, on the green or the blue hydrogen?
I would say, both. I think they will be developed in parallel, because right now, to kickstart, the hydrogen economy, you really need all options on the table when it comes to, carbon neutral hydrogen. To have enough supply to start kickstarting some end uses. Starting with green hydrogen, it can be very expensive. And so you would need blue which is the cheapest option now to produce to kind of kickstart these activities. But then, there's a consensus that by 2035, that globally, I mean, blue hydrogen and green hydrogen may be reaching parity. And so it'll be very competitive after that point. So, but I think in the short and medium term, I think the emphasis have been put on both.
All right. Thank you again, Rami. And I hope to see you soon in Saudi, because we'll be bringing Saudi Energy Meet to Saudi Arabia, and I'll see you in the event.
Absolutely.
Physically.
Yeah, my pleasure. Yeah, of course.
And look forward for your support. Thank you very much, and have a nice day ahead.
Thank you.
Thank you very much.